everyone. So our topic for today is all about sequence. So today we are discovering and learning new something in the chapter 10, which is the Introduction to Algebra, Lesson 1, Sequence. First, let us define what is sequence. So, sequence is a list of things, usually numbers, that are in order. So, I have here an activity, a word problem activity. So, let's answer. Jane arranges stamps in her album. So she arranges 4 stamps in the first page, 7 stamps in the second page, 10 stamps in the third page, and so on. So if her album has 10 pages, how many stamps are there on the last page? One way that we can solve this problem is by plotting the data in a table. So let's study the data. What do you notice with the number of stamps in the relation to the page number? That's right. The number of the stamps in the current page is 3, more than the previous one. If we continue to fill in the table, we came up with this data. Making a table to come up with the answer helps us in visualizing the given data, but listing many numbers may consume huge amount of our time. One way to easily do this is to write the data in a sequence and study the relationship among them. Based on the problem, we have this sequence, so the 4, 7, and 10. The 4 is the first term, and the 7 is the second term, the 10 is the third term, and the 3 dots is the ellipsis. So, each of the number that composes a sequence is called a term. The 3 consecutive dots, or the ellipsis, tells us that the sequence is infinite, which means that it goes on and we cannot identify the last term of an infinite sequence. On the other hand, a sequence is finite if the last term is known, if it stops in a specific number. So in the previous example, the 4, 7, and 10 is an example of an arithmetic sequence. Here's the formula of an arithmetic sequence.
The sequence is called a term. Here we have the first term, second term, third, fourth, fifth, sixth, seventh, and so on, which is the end term. Here, we represent the number or the order of a term by letter n. This means that the n represents the term. And each number or each value of a term can be represented by a sub 1, which represents the value of the first term, which is 1. A sub 2 represents the value of the second term, which is 3. A sub 3, which is 5, A sub 4, which is 7, A sub 5, A sub 6, A sub 7, and so on, which is A sub n. This represents the value of each term. Now that you already know what the sequence is, let us try to find out and solve for the next 3 numbers of this sequence. If the terms of a sequence increase, it may involve addition or multiplication. Here, we can see that the sequence increases. Now, what do you think? What should we do to number 1, which is the first term, to get the second term, which is 3? Great job! We need to add 2. If we add 2 to our second term, which is 3, we'll get 5. Next, 5 plus 2 is 7. Therefore, if we add 2 to 7, we'll get the next term, which is 9. And 9 plus 2 is 11. And then 13. These numbers are what we call the common difference, which is represented by small letter d. This means that the common difference is 2.